Maybe at the end of the period. So
no, it's necessary. I have to go to the next one. This is more. This works better.
You can put on my desk. I just don't have time to check it right now. Let's get the spreadsheet loaded up. Yeah. Okay. All right. Parametric equations. Parametric equations. All right. A parametric equation, and they're using the word curve because it could be a line, but it could be another shape. We're going to see parabolas and circles also in this lesson, is where our x and our y variables are defined by a different function that includes a t. T is what we call the parameter, which is where we get a parametric curve from. Okay, so to get our x and y, and we're going to practice graphing these in a minute so you can kind of visualize this. We have a function involving t that gives us our x coordinates. We have a function involving t that gives us our y coordinates, usually different functions, and then those x and y coordinates create a set of points that give us a curve. And we're going to identify certain curves, lines, parabolas, and circles, what we're going to mostly focus on in this, okay? T will have an interval. It could be all real numbers, negative infinity to infinity that were defined over, or it could be a certain set of numbers like, I don't know, -1 to 8, if it's only a segment of a curve that we're graphing. All right, so first slide that we're going to practice graphing a parametric equation with is as follows. So again, you will have separate equations that you're using for the x and the y. So x here is defined as t squared minus 2. Y is defined as 3t, so that t is our parameter, and t is defined on an interval here between -3 and 1. So that tells us what we are going to fill in our table. And we're just going to use the integers between -3 and 1. Okay? To get the x, you're going to plug the t's into the x equation. To get the y's, you're going to plug the t's into the y equation, and then we're going to plot our x and y's, and that's going to make our graph. All right, so to get the x's, I'm plugging it in t squared minus 2. So this is mental math, right? So -3 squared minus 2 gives me 7. -2 squared minus 2. +2. -1 squared minus 2. -1. 0 squared minus 2. -2. And 1 squared minus 2. -1. Okay, to get the y's, we're plugging our t into 3t. So 3 times -3, -9. 3 times -2, -6. 3 times -1, -3. 3 times 0, 0. 3 times 1, 3. Okay. All good? Okay, so now we plot x and y to get our parametric curve. So 7, -9, there, not there, okay. 2, -6, there, -1, -3, -2, 0, and -1, 3. And then it's only defined between these two values, so you're just going to make a smooth curve, no arrows on the end, just connecting all of those points. So what we see here is actually a portion of a parabola. This is an opening right parabola that you see here. Okay? Any questions on that one? Getting a parametric curve. Okay. Let's try the next one. Okay, for the parametric interval, we're going to graph these equations and hold on, let me see here. I think we had those same ones. Let's flip this here. Let's make this one the y and let's make this one the x. We'll flip it around a little bit. Okay. This time our parameter is defined between -2 and 3. -1, 0, 1, 2, 3. Okay, so to get our x's, 3 times each of our t's. -6, -3, 0, 3, 6, and 9. To get our y's, t squared minus 2. All right, so -2 squared minus 2. -2 squared minus 2. Gives me 2. -1 squared minus 2. 0 squared minus 2. 1 squared minus 2. 2 squared minus 2. 2. And 3 squared minus 2. 7. Plot your x and y's. All right, -6, 2. -3, -1. 0, -2. 3, -1. 6, 2, 9, 7. Okay, and again, we have a segment of a graph here. This one is a parabola opening up. You could even name the vertex on this one. Okay. Any questions? Getting the graph of a parametric curve. Using our t's, plugging them in for each x and y equation. All right, cool, moving on. Okay, next thing we need to worry about is, let's say that curve that we just graphed, I want to find the equation for it. So just an x and a y. I don't want that t in there anymore because that's causing a mess, right? So we call that eliminating the parameter. If I want to get rid of the t, combine these equations together and get one equation that just has an x and a y in it. So this is going to look like a system of equations that we've done before. It's going to be substitution. In one of the equations, you're going to solve for t. It doesn't matter which one, whichever one looks easier. I'm going to use the equation on the right. I'm going to solve for t. How do I get t alone? Okay, so subtract 2, y minus 2 equals -t. Divide by the negative, so -y plus 2 equals t. What t is equal to? Plug into the other equation. All right, so that will look like x equals 1 minus 2, take the t out, replace it with what we know it's equal to, -y plus 2. Simplifying, I have a positive 2y and a -4 when I distribute. Combine my like terms. I have a 2y and then +1 and -4, give me a -3. We have one equation that just has an x and a y in it, so we have our answer. It's just not in a great form. Normally when we graph things, we want the y alone. So I'm going to get the y alone then to be able to identify this. To get the y alone, add 3, and then divide by 2 or multiply through a half. And you end up with 1/2 x plus 3/2 equals y. What is that the equation of? Not a parabola. This is a line. And you need to describe the line. So to describe a line, I need two things. I need a slope. I need a y-intercept. What's the slope? 1/2. And the y-intercept is 3/2. Okay, so if you were to graph this, you would end up with a line that has a slope of 1/2 and y-intercept of 3/2. So you could skip that whole big table thing that we just did. If you can eliminate the parameter, you can graph it just using x and y like we're used to, and slope and y-intercept, and not even have to do a table at all for this example. Okay? Questions on that one? Okay. So let's say, same problem as before, we eliminated the parameter, okay, and we already did that. That answer on the previous page was it 1/2 x plus 3/2 that we just had a second ago? Yeah, okay. So that in itself was a line with that slope and that y-intercept. In the last problem, the t was defined for all real numbers, so it was a line that went forever in both directions. Here, the t is only described between 2 and 6. Our parameter is limited, which means it's going to be a line segment instead of a full-blown line. So if we want to describe this line segment, we would say it's a line. We would say the slope is 1/2. We would say the y-intercept is 3/2. We know all that stuff already. But then we'd also want to describe what the end points of this line are, where it starts and where it stops. To describe where the end points are, you're going to plug t, both 2 and 6, into both equations. We're going to find the x, and we're going to find the y. Okay. If I plug 2 into my x equation, 1 minus 2 times 2, what do I get? -3. If I plug 6 into my x equation, what do I get? I'm going to get -11. Okay. Do the same thing for the y. So it's like a mini version of the table that we did earlier. Plug 2 into your y equation. 2 minus 2 gives me 2 minus 2, 0, yep. And then plug 6 into your y equation. -4. Those are your endpoints, the x and y that go together. -3, 0 were both the values when t equaled 2. And -11, -4 were both of the values where t equals 6. So that's where this line starts and stops at. Okay, so you just have that extra step at the end. An alternative is you could find the x and then plug the x in to get the y that goes with it. I think it's just easier to plug t into both equations. Yes?
Will that be any different if you have like less than equal to?
So if I were to graph this because it's not equal to, I would put open circles on the end of it. If it was equal to, it would be closed circles if you had to make a sketch of it. You would figure it out exactly the same way though. It's just a matter of if it's equal to, not equal to on those ends. Yeah. Okay. Questions on that one? All right, so we did a line segment. The other one that we will look at is this guy, eliminating the parameter. So we did this a minute ago. We had, I can't remember if this one was the parabola open left, right, or up, down. I guess we're going to find out. All right, so I want to solve for t to get rid of the parameter. Would it be easier to solve for t in the y equation or the x equation here? Where is it going to be easier to get t alone? You don't have it? Okay, go up to the top on your Jamboard where the little slides are and just hit a plus. Write it in. Get yourself a new slide. Okay, so y equals t squared minus 2. X equals 3t. Parameters defined for all real numbers, negative infinity to infinity. All right, so if I solve for t in the y equation, that would involve a square root. So I'm going to solve for t in the x equation. Make it x over 3 equals t. Okay. It's a fraction, it's not ideal, but it's fine. And then we're going to plug that in for t in the other equation, do our substitution to eliminate the parameter. All right, so that would look like y equals X over 3 squared minus 2. What is x over 3 squared? Square the numerator, square the denominator. X squared over 9 minus 2. And then I would write it like this, 1/9 x squared minus 2. So can you see now that it would give us that parabola? Okay. One thing you need about, well, two things you need about a parabola. Which way it opens. Can you tell me if this guy opens up or down? It's a good review for our exam. How do you know it opens up? Positive. Actually, well, no, this won't be on this exam. That was last semester I'm thinking about. And then you also need to know the vertex, which was HK. You could also do the negative b over 2a formula. Now this guy is in that standard form already. You can write that x as x minus 0 squared, like this. And then h was the number in the parentheses, the opposite of the number in the parentheses. K was the number by itself. So the vertex here is actually 0, negative 2, which if you look back at the graph we had, that was the bottom of that parabola. It was 0, negative 2. But you can see it in the equation now as well. So that alone would be enough to be able to graph this. If I had that it opens up and I had the vertex, I would be able to make a rough sketch of it. Okay? All right. So that's a parabola, eliminating the parameter. Do you have this one on there with the 2 cosine and 2 sine? Yes? Okay. So this one is going to be the third shape that we haven't seen yet. What we're going to start by doing, if you see a sine and a cosine, to eliminate the parameter, we are going to square both sides of both equations. That will give me x squared equals, and I'm just distributing it in, there's no plus or minus here, so I don't have to worry about foiling, 4 cosine squared. And y squared equals 4 sine squared. Then we are going to add those two equations together. What's on the left will be on the left. What's on the right is going to be on the right. So that's going to look like x squared plus y squared on the left. And 4 cosine squared t plus 4 sine squared t. Both of those have a 4 in them. So what can I do on that right side? Factor out a 4, and if I factor out a 4, I'm left with cosine squared plus sine squared, which is why I squared both sides. Because if I have cosine squared and sine squared, not just cosine and sine, I know that's equal to what? It's equal to 1. So I am left with x squared plus y squared equals 4. What is that the equation of? That is the equation of a circle. And this is already in standard form of a circle. You can write x minus 0 squared, y minus 0 squared if you want, but it has a center at 0, 0, and it has a radius of square root 4, so 2. Now this circle, the reason they give the parameter 0 to 2 pi is it follows our entire unit circle. It's a full rotation. The circle is complete. At the bottom, I added a little question here. I said, what would change if t was defined between pi over 2 and 3 pi over 2? Well, if t is defined between 0 to 2 pi, I get a whole circle. So if I only define t between pi over 2 and 3 pi over 2, what am I going to see? I'm going to see a semicircle in quadrants 2 and 3. Does that make sense? Okay. All right. Questions there? Eliminating the parameter. So 2 and 3. All right. I think I only got like 5 more slides left. Let's just power through, finish it up today. All right. If you have to create the parametric equations, this is for a line. Let's say you have 2 points that you are going to create the parametric equations for, the line between those points. We have P0, 0.0, and 0.1. The parametric equations are described as follows. To get the x, I'm going to do the x coordinate from point 0 plus t times the difference in the x coordinates. To get the y, I'm going to do the y coordinate from point 0 plus the difference in the y coordinates. And then we'll usually define t between negative infinity and infinity. If you see that t isn't listed as defined between anything, for a line, it's assumed negative infinity to infinity. For a circle, it's assumed 0 to 2 pi. For a parabola, it's assumed negative infinity to infinity. Unless you see otherwise, we just assume we see the full shape. Okay, so that's what we're going to do on the next page. We're going to use this equation to create the parametric equations. Okay, so I have 2 line segments here, or 2 points that I'm going to create a line between. This is P0, so this is x0 and y0. This is P1, it's x1 and y1. Okay. We want to write an equation for x and an equation for y that both involve t. Here's how we get it. x0 plus t times x1 minus x0. That's the formula from the previous page. And then y0 plus t times y0, or y1 minus y0. Okay, and we're just going to fill it in. That's it. So x sub 0 is negative 2 plus t, subtract my x's, 3 minus negative 2. I end up with a 5t minus 2. 3 minus negative 2 gives me 5 next to my t. Negative 2, that's the equation for x. To get the equation for y, y0, 3, plus t, y1, 6, minus y0, 3. 6 minus 3 gives me 3 with my t, plus 3. And you have parametric equations that describe a line. Unless we are told otherwise, we assume t is from negative infinity to infinity. Okay, so that's working backwards. We have the points, we work backwards to find the equations. Questions on that one? Okay. If we want to write the parametric equations for a circle, where the center, here they don't use HK, they use PQ, and the radius is R, our equations look as follows. It's going to have a cosine and a sine like the one we saw earlier. To get an equation for x, we're going to do R cosine plus P, where P is the x coordinate of the center. To get y, we're going to do R sine T plus Q, where Q is the y coordinate of the center. Just like our unit circle stuff, just like our vectors and our complex numbers, all of that stuff, x goes with cosine, y goes with sine again. Right? Unless you're told otherwise, we assume that t is defined between 0 and 2 pi. And they do have brackets on either end of this, so when we write it with inequality symbols, we'll use equal to for both. All right? Okay. So let's do one of those. Find the parametric equations for this circle. You need 2 pieces of information. You need the center of the circle and you need the radius of the circle. This one is already in standard form of a circle. What is the center? 4, -1. That is the P and the Q that you're going to use in your equations. What's the radius? Square root of 36, 6. So that's the R we're going to use in our equations. All right, writing an equation for x and y. R cosine t plus p and R sine t plus q. Just fill it in. 6 cosine t plus 4 and 6 sine t minus 1. You could even work backwards. If you have the parametric equations, you could use this formula to say, okay, there's a 6 in front of both the sine and the cosine, so I know that's going to be my radius. I know what's with the cosine is the x coordinate of my center. I know what's with the sine is the y coordinate of my center. So you could use that to save yourself a little bit of time when you're eliminating the parameter. If you recognize the set of equations, you know what you're going to get in the end, and you can save yourself a little bit. Okay, and again, t, I'm going to define, unless we're told otherwise, between 0 and 2 pi. Good on that one? Okay. Last problem. Same type of question. We want to write the parametric equations, find the parametrization, I'm terrible at saying that word, of the circle. The only difference here is it is not in standard form of a circle. So the thing you have to do is complete the square, which we practiced recently, but we'll review that a little bit. Completing the square, get your x's and y's together. X's, y's, and then if you have a constant you want it on the other side, that 2's already over there. You guys had a problem like this on the quiz yesterday where there was both an x term and a y term. That means you are completing the square twice. Do you remember how to find the number that we're going to add to our x's and y's? Half it, square it. So start with negative 16. If I half it, square it, what do I get? 64, add it to both sides. Then use 6. Half it, square it. What do you get? 9. Factor your x's, factor your y's. If you factor your x's, it's going to be a parentheses times itself, a parentheses squared. What do you get? X minus 8, or x minus 8 squared. Factor your y's. Two numbers that multiply to 9 and add to 6. What are they? Y plus 3, or y plus 3 squared. And then on the other side, I've got 64 plus 11, so 75. What's the center of this circle? 8, negative 3. What's the radius of this circle? Square root of 75, which breaks down 5 rad 3. Okay? That is enough to write your parametric equations. X equals R cosine t plus 8. Y equals R sine t minus 3. That's, again, my P and my Q in that center. And unless we're told otherwise, t is from 0 to 2 pi. And that is everything you need to know about parametrics. That is the last section I will teach you this year. How do we feel? We learned all of trig. We're done. All right. You have earned yourself a Math Excel work day tomorrow. Not a Math Excel, a work day tomorrow. I'm so used to saying Math Excel work day. A work day tomorrow. 2, 3, 4, 5.
What? What's this?
10 questions. 10 questions. Your last homework assignment. When does it due? It is due on Friday.
Oh.
At the latest. Honestly, you guys will get it done in class today. Real quick, guys. Number 3, switch the x and the y in the equations. Make y equal to t squared, okay, and make x equal to t plus 1. Number 3, switch the x and y.
No, where's my pencil?
All right, so 10 homework problems due at the latest when you come into class on Friday, but again, you've got all periods today and all periods tomorrow to work on it. Whenever you're done with this done, you guys can start looking at the final exam stuff. Get ready for next week. Questions for me?
Number 3, that isolation is
Number 3, where we're yes, yeah.
Yeah, I just think it's-
Okay, I'll do cell phone lotto and we are done.